Hello guys, in this video we are going to talk about 2D rotation. In last video we dealt with 2D translation, where our intention is to, in a coordinate system, if we have an object given the offset distance that uh, the object has to be moved, by adding that offset distance to the current coordinate points of the object, we move that object from one point to another. So it's basically like this. So we have offset values, that is tx and ty. We have x and y. To this x and y we add offset values and we get x dash and y dash. So in this video we are going to talk about 2D rotation. So the problem of 2D rotation is, say suppose I have my x and y axis like this. I have a point P which is determined by x comma y, and now this point has to be rotated by angle. So let us say from origin this is at a distance of r, right? Now this point has to be rotated by an angle, let us say theta. So it's basically like this, right? So the distance will still be r here, and we will call this as p dash, and these points shall be x dash and y dash. Now in order to do this, so over here what all we know x and y points of the given x and y values of the given point, and then the theta with which we are supposed to rotate, right? And these are the things that we would know. We would not even know what is r over here. It's just an imaginary value that we have considered here. Now our intention is to represent x dash and y dash in terms of x and y. Just like how we did in translation, we represented x dash and y dash in terms of x and y plus something, right? So similarly we have to represent our x dash and y dash such a way that it is represented in terms of known things. So right now what we know, x and y and theta is what we know. So we have to represent x dash and y dash in terms of x and y and theta. So how to go about it? Now for doing that, I'll just consider this triangle over here. Let us say there is a angle phi that is happening, right? This angle phi is nothing an angle that this point is making with respect to origin and x-axis, right? Then I can give this distance with x and this distance with y, correct? Now I can represent my I can take cos phi, and this can be x by r, that is adjacent by hypotenuse, and this is a right angle triangle here. So similarly I can have sine phi is equal to y by r, that is opposite by hypotenuse. Now can I represent x in terms of r cos phi? Absolutely. Similarly I'll represent y in terms of r sine phi. Right, now let us take this triangle, right? So this distance will be y dash, and this distance will be x dash. In a similar terms I can write my x dash as r cos of this complete angle. So now this angle is supposed to be in terms of with respect to origin and x-axis, right? Now this is theta plus phi, right? So this complete angle, this is a 90-degree angle, this one is a 90-degree angle here, and so this angle is what we are going to take. So this is theta plus phi, and y dash will be r. So something like this. Now I can expand this as cos of a plus b is r cos phi into cos theta minus r sin phi into sin theta. And similarly, I can represent this as r cos phi into sin theta plus cos theta. Now we already know that our x is r cos phi and y is r sin phi, so we have this term, right? We can replace them. So I can represent my x dash and y dash as x cos theta minus y sin theta. Y dash is x sin theta plus y cos theta. So now if you see, I have represented my x. So over here, what all I know my theta and x and y. I have to represent my x dash and y dash in terms of theta and x and y, as in terms of known values. So that's what I have done. My x dash and y dash is in terms of x and y's and thetas, cos and sine of the angle with which I am supposed to rotate. What is theta? The angle with which I am supposed to rotate from the original position of the object with respect to origin and x-axis, right? From here, by theta angle, I have to rotate in anti-clockwise direction. So this is a direction, anti-clockwise direction. This we have to remember. Now these are the equations in order to rotate it, but as we have seen it in translation, we have to represent this in terms of matrix. So how to do that? As usual, I'll take our p as x and y, and similarly I'll take p dash as x dash and y dash. Now I have to represent my p dash in terms of something of p, right? So that's what we have seen in translation also. So what matrix multiplication and what will be the matrix that can define, give me this operation, this equation, that matrix will be treated as my rotation matrix. Now see here, I have my x and y over here. So I can write it as x and y dash is equal to something, and I have my x and y. This should give me x cos theta minus y sin theta, and x sin theta plus y cos theta. This is what it should give me. So what is the matrix that fits in here, and what is the operation that will come over here? So that's what we are supposed to do now. So for that, I'll take a matrix called as R, which is nothing but rotation matrix, and I will take it as cos theta. If you think, you know, x and y I have it, so x and y minus y of sine theta it should give for the first row, and for the second row something of sine theta plus something of y cos theta should be given. So how do I get it? For that I'll take it as a, take a matrix which is minus sine theta. I have taken this as minus because I have a minus sign over here, right? This will be sine theta and this will be my cos theta. So I can multiply this matrix with this matrix and get this. Cos theta. Right, if you see here, cos theta into x is x cos theta plus minus sine theta into y, that is minus y sine theta. That becomes my first row. Again I'll go over here, x into sine theta plus cos theta into y. So this is what I'll get. Now I can represent it as x dash is equal to R, that is this matrix, into, that is matrix multiplication, and the point that I have, if I multiply these two, the resulted point that I would get would be the values of rotated point by theta degree in anti-clockwise direction, right? So that's why now guys, this matrix R is equal to cos theta minus sine theta and then cos theta. So this guys is called as two-dimensional rotation matrix, and this is the rotation operation. So guys, that's about 2D rotation. So in the next video, we'll be learning about 2D scaling and some other operations. Thank you guys.